Hi, my name is Leonardo Frid, and in this video I'll be giving you an overview of the Caribou Cumulative Effects Model framework. This is the first of a series of 4 videos. In this one I'll be covering concepts behind the Caribou Cumulative Effects Model, and in subsequent videos I'll be giving you step-by-step guides on installing the software. I'll give you an introduction to the full version of the software, and I'll give you a step-by-step tutorial on using a simplified version of the Caribou Cumulative Effects software. Now, before I begin, I'd like to spend a bit of time talking about cumulative effects. This is a term that's often used, but not always clearly defined. So when we think about cumulative effects, we usually like to start by thinking about the things in the ecosystem that stakeholders care about. In the case of the Caribou Cumulative Effects Model, this is caribou populations and questions such as whether a population may be declining or increasing, whether population numbers are sufficient to ensure the long-term survival of a herd, and whether a particular rate of hunting may be sustainable into the future. Once we have these questions, we can then think about the measures that affect the answer to these questions. So these measures might include things like the risk of harvest to an individual caribou, the body condition of an individual caribou, things like its weight and its fat and protein reserves, and survival rates and birth rates of caribou across the population. And once we've thought about these measures, we can then think about the stressors that will ultimately affect these measures. And these stressors might include industrial developments within the range of a particular caribou herd, which will affect caribou activity and stress levels, climate, things like how much snow there is, which might affect the energy requirements of individual caribou, and hunting and predation rates, which will ultimately affect mortality rates across the population. So when we think about the combined effect of these stressors, that's what we're talking about when we talk about cumulative effects. We're talking about the combined effects of multiple stressors on caribou populations. And the Caribou Cumulative Effects Model was developed to help stakeholders evaluate the effects of these multiple stressors on caribou populations. So the Caribou Cumulative Effects Model is a simulation model, and I'd like to spend a little bit of time talking now about what a simulation is. A simulation model makes projections into the future. It takes a series of assumptions, or what we call model inputs, and runs them through a set of calculations to then produce a projection or model output of what we think the future might look like based on those input assumptions. Now, because there's often uncertainty around the input assumptions, we often work with scenarios. So a particular scenario might represent a particular set of input assumptions and have a corresponding set of output projections. And we could change the input assumptions for a second scenario and have a different set of projections for a possible future. Now, the Caribou Cumulative Effects Model is unique in that it combines 3 simulation models into one. So we begin with a set of spatial inputs when we want to run the Caribou Cumulative Effects Model, and the first of these is a map of past caribou locations based on GPS collar data, and the model will then use these past locations to simulate potential future caribou movement patterns on a landscape. Now we need also some additional information about this landscape, and by the way, this polygon here as an example represents the range of the Bathurst caribou herd. So across this range, we also need to represent as an input potential future vegetation. And the simulation model will use this information to determine possible food available to caribou that are moving across this landscape. Across the same range, we need a map of different climate zones, and these climate zones will then be used to represent climate conditions experienced by a particular caribou on a particular day. things like snow depth and temperature. And we also need as an input a map of potential future development. And so this map may be represented using different assumptions. For example, assuming no further additional developments are added to the landscape and just using a map of what is there today, as opposed to a set of assumptions that might be representing what if all proposed developments were added to the landscape. So these maps are then used as inputs to the movement model, and the movement model then projects potential future forage availability, snow depth, and activity levels for caribou moving across this landscape. These values are then inputs to the body condition model, which in turn projects future survival and birth rates, which then become inputs to the third model, which we call the population model. The population model also requires the current population size of a particular caribou herd, as well as planned future harvest levels. And once we've run all of these inputs through the Caribou Cumulative Effects Model, we can then produce future projections of population size. So if we define a particular scenario, say for example, adding developments and roads to the landscape and setting a future harvest rate of 3% of the population, we can then make a projection of what the population size might be in the future. And then we can define an additional scenario where we change those assumptions, say no additional developments and roads, and a harvest rate of only 2%, and produce a corresponding projection for that second scenario of future population size. Now to run the model, we've developed simulation software. And this software is co-developed by ApexRMS, Don Russell, and Bob White. And it's available for free download. As I mentioned earlier, we have additional video tutorials on downloading, installing, and using the software. And you can find out more at apexrms.com. So if you go to our homepage and scroll down, you'll see a recent project called Caribou Simulation Model, and click on the details. Thanks for listening.